Okay, welcome back, Trig kiddos. This is section 5.4. Don't know if we're having school today or tomorrow. Well, I know we didn't have it today, but this is scheduled for tomorrow, Thursday, and regardless whether we have it or not, I am going to be gone. I have a family funeral that I also have to sing at, so it's going to be most of my day. So this still needs to be getting done, so I recorded this for you. After yesterday's video in section 5.3, this is section 5.4 and should be a little easier. Okay, so let's take a look if my board will catch up with me. So we're talking about more trig graphs. Okay, we talked about sine and cosine in the last section, 5.3. This one is about all the others: tangent, cotangent, cosecant, secant. Once you understand how sine and cosine work, the rest of these are pretty straightforward. Now, we start off with tangent and cotangent. The big thing they're talking about here in these periodic properties is that tangent and cotangent repeat every pi. Okay, that's their period. We learned in section 5.3 that sine and cosine, their period, their graph repeats, if you will, every 2 pi. Okay, you got to make it a full cycle around the unit circle, if you will, 2 pi, in order to get one full complete cycle of the graph of sine or cosine. For tangent and cotangent, because they're fractions, remember tangent is tan is sine over cosine. Of course, those are dead spots on my board. And cotangent is cosine over sine. Okay, so if you're talking about this, then if you did all the math, and you'll see here in a chart in a minute, but the periods for tangent and cotangent are just 1 pi, not 2 pi. However, cosecant, its period is 2 pi because if you remember, it is 1 over sine. That's how we get cosecant. It's the reciprocal of sine. Secant is the reciprocal of cosine. Okay, so that's what secant is. So because cosine has a period of 2 pi, then secant also has a period of 2 pi. So sine, cosine, cosecant, and secant all have periods of 2 pi. Tangent and cotangent have period of 1 pi. Okay, now, generally speaking, what this is talking about is that when we graph tangent, it generally, to get the full graph, we graph it from negative pi over 2 to positive pi over 2. Again, if you add those, the absolute value between the two is 1 pi. So that shows you both sides of 0, and it going up and it going down. For cotangent, it's just regular 0 to pi. But let's look here. So they talk about all the different values of tangent. Look what happens. This gets bigger and bigger and bigger and bigger, okay, as you get higher on your x values. Your tangent gets bigger and bigger and bigger. Now, this is approaching, okay, pi over 2. That's what that's approaching, all right? So at pi over 2, we're getting nearing pi over 2. That doesn't equal pi over 2, but it's approaching it. We go up. We essentially end up having asymptotes. Now, let's talk about why we have asymptotes. Okay, again, if tangent is sine over cosine, what can we never divide by? Cosine. Well, when is cosine 0? Cosine, if you remember on your unit circle, cosine is your x-axis. So cosine is 0 at pi over 2. Okay? 3 pi over 2, etc. Okay, cosine of x is 0 at pi over 2, 3 pi over 2, etc. So that's why we have these asymptotes. I don't know if you can see me drawing over the blue dashed lines here. That's why we have these asymptotes at pi over 2 and negative pi over 2. If we continued this graph to the right, it would go from negative or from pi over 2 to 3 pi over 2. Okay, would be the next asymptote. So that's why we have vertical asymptotes, okay, at those points, because that's where cosine is 0. So to show the repetition of the sine of, or the graph of tangent, here's what many graphs of tangent looks like. And again, every pi, okay, that happens to be at the breaks of pi over 2, but again, notice here your period is pi. That's pi width, from negative pi over 2 to positive pi over 2. That is pi width. That's a period. And it just keeps repeating. So again, at all of these spots that I'm circling here, all of these spots, cosine is 0. That's why we have the asymptote, because tangent is sine over cosine. Now, conversely, cotangent, okay, is, if you remember, cosine over sine. So again, we can't divide by 0. That's where we blow up and need our vertical asymptote. So where is sine 0? Sine of x equals 0. If you remember your unit circle, sine is like your y-axis, right? So it is 0 at 0, pi, and so on. We could go negative pi, we could go 2 pi, 0 pi, 2 pi, I'll just put dot, dot, dot. Okay, so every pi, we have a 0 for sine. That makes the vertical asymptote for the cotangent function. Okay, again, this width, here's the asymptotes at 0 and pi. This width right here is the period, which is pi. Okay, and now notice on the tangent graph, it goes up and to the right and down and to the left. On the cotangent graph, it flip-flops. It goes up and to the left and down and to the right. Okay, it's sort of a similar shape to like a cubic function. Okay, now, so since cotangent x is undefined for x equals n times pi within any integer. So again, it could be pi, 2 pi, 3 pi, whatever. Its complete graph in figure 5b has vertical asymptotes at these values. All of these values, okay, whoops, not there, are where sine is 0. Those are your vertical asymptotes. Okay, now, let's talk about cosecant and secant. I'll be honest, I hate graphing cosecant and secant. The way I graph these every time, and you'll see when I do some homework problems here in a minute, I graph these by literally first graphing the sine or cosine function and then putting the, like what kind of look like parabolas on the top and bottom of the humps of the sine and cosine function. That's how I end up graphing these. So you can see here, by this one, we're first talking cosecant. So notice in blue here, they graphed, I'm tracing it here, they graphed the sine function. Okay, that's the normal sine function. Starts at 0, goes up to 1. At pi, it hits 0 again, comes back. Now again, every time it hits 0 is where we are on the cosecant function going to have a vertical asymptote. Why is that? Again, cosecant's 1 over sine. Sine is 0 at 0, pi, 2 pi, and so on. So that's where our vertical asymptotes go. This is also, I don't know if you can see me tracing the y-axis here, that's also an asymptote. Okay? So what happens then for the graph of cosecant is you literally take the very tip of the first wave, if you will, and then you draw a U between the two asymptotes that touches the top of the wave. Because again, at the top of the wave, what's the value of sine? 1. What's the reciprocal of 1? 1. Okay, so then it just goes the opposite direction. So again, this then, again, I don't know if you can see me tracing that. It just goes the opposite direction at the top and bottom of each hump. Okay, so again, reciprocal of -1 is -1. So they share that point at 3 pi over 2. So at 3 pi over 2 and at pi over 2, cosecant and sine have the same values because they're either 1 or -1. Okay, and then you draw your humps. So this is how I always graph it. I always graph the sine first and then draw in the cosecant behind it. Same thing with secant. Okay, secant, again, still has the period of 2 pi. It looks a little weird here. But remember that your cosine function starts at 1. Okay, cosine starts at 1 and then goes down. Okay, sine starts at 0, cosine starts at 1. So here, every time the cosine function is 0, that's where we're going to have those asymptotes. Okay, and again, at the top or bottom of each of the humps, if you will, for cosine, that's where we draw our secant. Okay, so it's just opposite. All right. Now, these have the same shifts and everything that we're used to. Okay, so don't be worried about that. This is just more about periods and whatnot. It says it is apparent that the graphs of y equals tan x, y equals cotangent x, y equals cosecant x are symmetric about the origin, whereas y equals secant x is symmetric about the y-axis. Remember, cosine was an even function, okay? So secant is an even function. Cosine was an even function, so secant was an even function. Now, tangent and sine are odd functions, okay? Tangent and sine are odd functions. So cosecant would be an odd function as well. And since tangent's odd, that means cotangent would be odd as well. It's reciprocal. So even or odd, reciprocal functions of even or odd functions stay, okay? Okay, let's talk graphs here. Just like before, we have amplitude. Remember, if they ask you for amplitude, it's always absolute value. And this determines our period. Remember, period for tangent is just pi, not 2 pi. So the period would be pi over k. And of course, that's a dead spot on my board. Seriously. I tried to rewrite it. Anyway, period is pi over k. So instead of 2 pi, okay, tangent and cotangents periods by default are just a single pi. Okay, so if you've got a k in your equation, you've got to divide by k. Nothing new really there. And again, they tell you here, period is pi over k. A is still amplitude. Now, let me say something about amplitude, though. Amplitude doesn't really matter on tangent and cotangent. Why? Because they go up, both tails go up to infinity. So it doesn't really matter. Every time I draw tangent or cotangent, I start at 0 anyway. And I either go up to the right or up to the left, depending on whether it's tangent or cotangent. So A doesn't really matter for tan or cotan. Okay, I shouldn't probably say that as a math teacher, but A doesn't really matter for tangent or cotangent. All the amplitude's going to do is make us go up faster. Okay, if you're just drawing a general graph, you're never going to know what the amplitude is. Okay, now if you're down in the weeds and you're pinpointing a bunch of points, then yeah, the amplitude's going to matter. But if you're just looking at an overall graph from like a bird's eye view, amplitude on tangent and cotangent does not make a hoot. All right. They were talking about, again, tangent starts at negative pi over 2 and then goes to pi over 2. So if you've got k involved, you got to kind of make those adjustments. And cotangent goes from 0 to pi. So again, if you have k involved, you got to make those adjustments. Okay, graph each function. Again, what this 2 does is tell me my period is going to be pi over 2, which is just pi over 2. I mean, it doesn't reduce or anything. So if I'm graphing, and you'll see here, I'll let them do it. They're better at it. that's going to change my period. Instead of, let's see if they've got it here. I guess we're not going to get it till the next one. So this one over here, again, this is my K. Okay, so period is again pi over 2. Again, another dead spot. This is my shift. This would be a shift right, pi over 4. Okay, shift right, pi over 4. Same kind of thing we talked about in 5.3 with sine and cosine. Okay, so what they're talking about here is the period in part A. The period is pi over 2. An appropriate interval then is negative pi over 4 to pi over 4. So again, tangent, we always kind of start at 0. The right tail goes up, the left tail goes down. If we're going to cut the period in half, okay, normal period is pi, we cut it in half, so now we have pi over 2. Then we've got to cut the normal asymptotes. Instead of the asymptotes being pi over 2 and negative pi over 2, they're going to be pi over 4 and negative pi over 4. We just cut them in half. So again, this right here, let's see if you can, this whole period is pi over 2. Okay, from negative pi over 4 to positive pi over 4 is pi over 2. And again, amplitude doesn't really matter. I don't even remember if those had an amplitude. But the period is the big thing. Again, tangent, you always start at 0, 0, 0. Wasn't shifted on that first one, but it just scrunched the period down to half. Okay. The next one, remember we had that right shift. So instead of starting here, let me do it in red. Instead of starting here, again, dead spot, we moved over to here. So instead of starting at 0, 0, we started at pi over 4, 0. And again, I want to point out that this period is pi over 2. Right leg goes up, left leg goes down. Okay, same kind of shifts and whatnot as we had sine and cosine. Okay, this one, I don't know if you remember, but the K is inside the parentheses. So what we would have to do first is factor out K. Okay, so that would give me, if I factor out the K, that's going to be x minus pi over 12. Okay, how do I know it's pi over 12? Because pi over 4 divided by 3 is like pi over 3 times 4. Okay, I'm dividing that 3 out, so it goes on the bottom with the 4. So again, this is my K, which means my period is going to be pi over 3. Okay, and it's going to have a pi over 12 right shift. That's what that tells me. Okay, and of course the amplitude is 2, but on a cotangent it doesn't really matter. Okay, they're going to go through what I just did. So here we go. I keep thinking, there's the graph. I'm a picture person. So again, on cotangent, if you remember, it typically has a 0 at pi over 2. Okay, so we squished it and then we shifted. Okay, so this, like your regular cotangent function, let me draw the regular cotangent function over here. Regular cotangent function, this is pi over 2, this is pi. Regular cotangent function looks like this. Okay, that's what the regular cotangent function looks like. Left tail up, right tail down. 0 is at pi over 2. Well, we squeezed the period to pi over 3. Okay, so we squeezed the whole period and then we shifted right. So that, it looks a little funky, but that's why this, let me do it in red, is at pi over 4. Okay. So we squeezed the period and then shifted right. So from here to here is pi over 3. 5 pi over 12 minus 1 pi over 12 is 4 pi over 12, which is 1/3 pi, or pi over 3. Okay, I hope that makes sense. Okay, Cosecant and secant, again, same thing. I want to point out, though, the period is 2 pi over k again. Okay, now on amplitude, amplitude does matter because it's where your hump's going to start. Okay, and you'll see what I mean here in a minute. And again, your k is still 2 pi divided by k. So on this one, actually, let's look at b here real quick. First, I'd, again, have to factor out the 2 over here. Again, another dead spot. So this would be x plus pi over 4. Okay, now my k is 2. So my period would be 2 pi over 2, or just pi. Okay, so I'm squeezing it a little tighter. And I have a shift here. This would be a left shift of pi over 4. Okay, now cosecant is the reciprocal of sine. Okay, also I forgot this. This is my amplitude. Okay, cosecant, and you're going to see this, but cosecant is the inverse of sine. So if I'm doing this myself, I'm literally drawing out sine with all of those shifts and amplitude and stuff. I usually do it in like dashed lines, just lightly on paper. And then I'm going to draw the humps of the cosecant above and below. So I'll show you what I mean here. They draw prettier than I do. So, okay, so this is the first one. That was just 1/2 cosecant 2x. Okay, 1/2 cosecant 2x. They have that down here. Okay, notice here, that's a half. Okay, that's what our amplitude does for us. Instead of starting at 1, we start down at a half, and then we have what look like parabolas. They're not really parabolas, but they kind of look that way. Okay, and again, notice that your full period here, full period is pi. Okay, because we had to take 2 pi divided by 2. So full period is pi. Okay, next one where we have to shift. Again, they factored out the 2, got pi over 4. Now, again, and they shifted left. From here to here, okay, is pi. That is pi width from here to here. Again, dead spots. Oh, they're killing me. From there to there is pi. Okay, that's one full period. So again, they shifted left here to negative pi over 4. Okay, shifted left pi over 4. So now I'm centered, again, I'm at a half. Okay, and then you go up and you go down. It's on the top and the bottom of the sine humps, for lack of a better description. Okay, let's look at secant. Again, what happens if our k is a half? Okay, that's going to stretch it out. So if your k is a half, again, that means your period is 2 pi divided by a half, which is 2 pi times 2, or 4 pi. So this stretches it. Okay, so that's what's going to happen here. So yeah, notice, again, from here to here is a full cycle. That is 4 pi in length. Okay, from here to there is 4 pi. That gives us one full period. Okay, and again, this is the secant function, so it is on top of the cosine, if you will. Now, let me kind of, just for kicks and grins here, this is what the cosecant, well, let me just draw it, would look like. Okay, we're just drawing on the humps of the cosine function. Okay, secant is drawn on the humps of the cosine function. So again, when I'm drawing these myself, I'll draw those first. Okay, now let's look at our homework assignment and do some of these. Find the period and then graph the function. Okay, easy peasy. Period on this sucker didn't change. We did not have a k. No k. So my period is pi. Now, what does the negative 3/2 do for us? The 3/2, not so much. It's 1.5. It's not really, my amplitude doesn't matter. However, this is going to flip it. that negative in front is going to flip it. So generally, okay, let me just graph you generally what the tangent function would look like. Okay, your tangent generally goes up to the right, down to the left. But we have flipped, okay? And we have these asymptotes. Not sure what's going on there. We have these asymptotes. Huh, okay. So now, if we're flipping, I'm doing this. Okay? So instead of tangent starting at 0, 0, right tail up, left tail down, I flipped it. Left tail's up, right tail's down. Okay? Next one. Sorry, I'm trying to figure something out on the screen here. Okay, next problem. -4 cotangent x. Again, period, we don't have a k. No k, so my period is still just pi. Now cotangent, you remember, generally goes, I'll try to do the asymptotes in blue, generally goes from 0 to pi. Tangent again goes from -pi/2 to +pi/2. Now again, we have this minus out in front. So once again, it flips. So instead of the left tail going up and the right tail going down, again, we flipped. So now it, whoops, I said we flipped and then I went to draw the regular one. I don't know why we keep. So now we have that. Okay, that is cotangent. All right, 1/2 cosecant x. Now the period, once again, we don't have a k, so the period is 2 pi. All right, now this is where, and it says our amplitude is 1/2. So I'm going to label this, this is 1/2, 1. This is -1/2, -1. Okay, so here's what I do first. I alluded to this when we were on the PowerPoint. I'm going to first draw the sine function. Remember that cosecant is 1 over sine. So I'm first going to draw the sine function. Okay, actually let me do it in purple. It's a little... Now, didn't change my period at all. Okay, so if I'm drawing sine, it's going to look something like that. That's going to be my sine function. My amplitude is 1/2. Sine starts at 0, 0. Okay, it goes up. It's back to 0 at pi, and then down and back up. Not the best drawing, but you get the idea. Now again, when we talk asymptotes, every place your sine function is at 0 is going to be a vertical asymptote for the cosecant function. Okay, so if I'm drawing these, my cosecant function is going to look something like that, and then something like that. The parabolas are really kind of fat on the bottom. That's going to be my cosecant. Okay, again, it's drawn on the top or the bottom of each of the humps, if you will, or the waves of the sine function. And every time sine is 0, you've got an asymptote. Okay, next one, 5 times secant x. Now again, on this one, I'm going to label these at like 2, 4, 6, -2, -4, -6. Get another dead spot. Okay, so secant, okay, remember, is 1 over cosine. Okay, so I'm going to kind of draw the cosine. Now, our amplitude is 5. Okay, so essentially what that means is my graph, okay, would be here at 5 and down to -5. Now, if I draw the cosine function, because secant is its inverse, if I draw the cosine function, if you remember, it starts at 0, 1. But my amplitude now is, let me see, yeah, is 5. So I'm doing this, okay? So I am going Actually, let me do it in purple again so it's a little less. So I'm going down right there. That's like the first half. Again, not the best drawn. But then we go back up. 2 pi is my full period for cosine. Okay. And again, down here is -5. Up here is 5. Here is 5. Now again, this is where you're going to have asymptotes. Okay? Your asymptotes are once again wherever your cosine function is 0. So here's an asymptote. Here's an asymptote. If you wanted to continue it on the other side, it would be here. It would be there. All of those are asymptotes. Okay, you could continue this on both sides of the y-axis. So then if I go in and draw my secant, again, it starts at the top of the hump or the wave, and then it goes up both directions, starts at the bottom, goes down, so on and so forth. This goes up, yada, yada, yada. Okay, that is secant, inverse of cosine. Oh, and we didn't put the period. The period, we don't have a k. So again, the period's 2 pi. Okay, nothing has changed the period at all. Okay, now we're back on tangents. Now we got some shifts. Okay, so again, amplitude on tangent, the 2 doesn't really matter. However, this matters. So this is a shift right pi over 4. Now again, they asked for the period. We don't have a k. So since k equals 0, the period on tangent and cotangent is just pi. Okay? So first of all, if you remember, regular tangent goes from -pi/2 to +pi/2, generally. Now, we just shifted right we shifted right pi/4. Okay? We shifted right pi/4. So that is going to make my asymptotes here and here. I'm going to erase the original ones. Oh my goodness. What in the world? Not real sure what happened there. Oh my gosh. Okay. Technology is not loving me today. Okay, good enough. Now, those are my asymptotes now. Okay? So because I shifted right pi/4. So now find the center of that. Okay? This is your 0 for your tangent then. Instead of being 0 here at the origin, this is now pi/4. We shifted right pi/4. And again, if you remember, the tangent function goes up and to the right and down and to the left. That's it. Okay, let's keep going. This one, same thing, cosecant. Again, it shifts right pi/3. And we do not have a k. Our k is 0, so our period here is still 2 pi. Okay, now we can again fill in our graph. This is 2, 4, this is -2, -4. Because we have an amplitude of 4, we're going to be going up and down at 4. So again, cosecant is the inverse of sine. Okay, so the sine function, let me see if I can add these points in here. So this, if I look at pi and divide it into thirds, it's like boom, boom. So this is like pi/3. This is like 2 pi/3. Boom, boom. This is like 4 pi/3. I don't know if you all can see this. And 5 pi/3. And then we have 2 pi. So the graph is going to be off a little bit. Okay. So we are shifting. So typically where sine begins at 0, 0, because cosecant's the reciprocal of sine. So where sine begins at 0, 0, okay, we're going to begin at pi/3. So everything's going to be shifted to pi/3. Okay, I should probably keep going over here somewhere. This would be like Well, that's all right. I will put like 7 pi over 3. I don't know. Okay, so if I'm graphing the sine function, because again, that's the reciprocal, from here to here's the top half. From here to here's the bottom half. Okay, so again, everywhere that I've got a 0, where my sine is 0, that's where my asymptotes are going to be. So I'm going to have an asymptote here at pi over 3. I'm going to have an asymptote here at 4 pi over 3. And then it would be over here at like 7 pi over 3. So those are going to be my asymptotes. And again, when I go back in then to graph the cosecant, okay, here in the middle, I'm going up and I'm going down. Okay, that would be my cosecant function. Okay, it's the red. So again, for whatever reason, I have to graph these by first graphing their reciprocal functions. Because in my brain, I just revert everything to sine and cosine. Okay, next one. Now we've got a k. All right, so find the period. So on this one, again, this is your amplitude. Okay, this is your k. So your period is 2 pi divided by 2, which is just pi. Okay, so the secant function, very similar to the one we just did, only our period is squished. So we're going to get it done in half as long. Okay, so there's no shift, but instead of going from 0 to 2 pi, you're going to go from 0 to pi. Okay, and again, secant's the inverse of the cosine function. Now, the graph actually goes with this next one. Find the period and graph the function. Again, here's my k. So remember, on the tangent function, the typical period is pi. So this is going to be pi over 2. Okay? Period is pi over 2. Typical period for tangent is pi. So we take pi divided by k. Okay, now if we graph this, okay, again, not real worried about amplitude, because on tangent and cotangent, you can't really tell it. So it doesn't really matter. But on this is a left shift pi over 2. So if you guys remember, tangent typically goes from negative pi over 2 to positive pi over 2. Well, we're going to have to squish it, okay, and move it over. So instead of starting here at the origin, we are shifting left pi over 2. So now it's going to start here. And with the period of pi over 2, that means I've got to have like pi over 4 on one side, pi over 4 on the other. Okay, I've got to do half the period on the right, half the period on the left. So half the period on the right, again, here would be my asymptotes. Okay, and this would be my function. We're not flipping, so right tail's up, left tail's down. This is what that would look like. Okay, again, we squished the period to half. Instead of going negative pi over 2 to positive pi over 2, we squished it to essentially negative pi over 4 to positive pi over 4, but then we shifted left. So again, this from here to here is pi over 2. Okay, that's my width. Okay, last couple. And then hopefully, I think our video last time was like 50 minutes. We're going to get out of here a little earlier. Find the period, okay? So this one is easy enough. Again, my k is 2, so it's a cosecant. Okay, cosecant, the normal period is 2 pi. 2 pi over 2 just means the period is pi. Now again, what all this other stuff means, this is my amplitude, that's my A, and this right here tells me that I shift left pi over 2. Okay? Now, this last one, this one looks a little weird, doesn't it? This right here, whatever's in front of the x has to be my k. I have to factor that out. Okay, so if I factor that out, this is going to be a 2 pi on the outside, and I'm going to be left with x minus a half. How is that? Because pi divided by 2 pi is 1 over 2. So that's what this becomes. This is 1/9 secant 2 pi parenthesis x minus a half. Now, your graph's going to look a little weird on here. You're going to have actual numbers and not the pi symbols. But that's okay. Let's still talk about k and our period. So this is our k. What does that do with our period? Well, if we go back to the drawing board, secant, again, reciprocal of cosine. Cosine's normal period is 2 pi. So our period is going to be 2 pi divided by k, which is also 2 pi. That just leaves us 1 is our period. Okay, even though it looks weird, you still got to do the math. Okay, factor out what the k value would be, and then take 2 pi divided by k to get your period if it's cosecant or secant. Take pi divided by k if it's tangent or cotangent. Okay, that is all for today. This is section 5.4. I am gone tomorrow, whether we have school or not, whether we have school or not Friday. This assignment's going to be due Friday night. Sorry.